Let me start our session with the minimization of 4 variable functions which are in SSOP form using K-map method. So now let me move to your procedural steps like into 3 variables. So the same steps only. So here also we are following. So select the K-map according to the given number of variables. So then identify your minterms as given in the problem. Thereafter we have to place your ones in the blocks of your corresponding blocks of your K-map with respect to their cells, as minterms functional values are 1, hence we have to put ones in their corresponding blocks. Next, make a big group or rectangular groups, so which contains only the minterms. So try to cover as many elements as you can. So try to select your big group only, not your small group. So if it is a 4 variable, then we would have 16 cells. Always we have to check for the double octet. So if it is not possible, then we'll move to the octet. If it is not an octet formation with the minterms, then we will move to your quad, which is a 4 square adjacency. If the quad is not possible with the minterms given, then we will move to your pair. So in the worst case, we will go to your isolated minterm. So if it doesn't find any minterm for adjacency, minterm of adjacency, then we will just write that minterm as it is. So group your adjacent minterms into pairs, quads or octets or double octets. After that, so for each group we need to write a product term, then sum your all the product term will give you the simplified expression. Upon deriving your simplified expression, we are going to design your circuit using logical gates as well as your universal gates. Now, so let I explain you this with an example. Now, first example, I have given a 4 variable function with the given minterms of 0, 2, 5, 7, 8, 10, 13 and 15. So now upon this given function, which is a 4 variable, as since my variables are 4 variables here A, B, C, D, and your given minterms total I have here 8 minterms are available. Now, so let me map your function by placing their ones in your corresponding cells. As it is a 4 variable, so choose your 4 variable K map. Upon choosing the 4 variable K map, then we will go for the square adjacency. So first one we will start with the 16 square adjacency with the given minterms. So here I have only 8 minterms are there. Now this 8 minterms are not at all adjacent to each other. So we can't form an octet. So next we will move to your next priority will be given to the 4 square adjacency, which is a quad. So now 5 is adjacent to 7, 7 is adjacent to 15, 15 adjacent to 13, 13 is adjacent to 5. So we can form a group which is a quad. Now the same, so this is the group 1, so which we indicated with the red one. So red square indicates, so a red group which is indicating a quad. So first quad I have here with 5, 7, 13 and 15 minterms. Next, let me move with another one. So here 0 is adjacent to 2, 2 is adjacent to 10, 10 is adjacent to 8, 8 is also adjacent to 0 because this 0 and 8, 2 and 10 are in right corner as well as in the left corners, or else so they are in the upper row as well as in the lower row. So of your minterms are there in your corners. So corner cells are adjacent here. So hence we can make a quad with 0, 2, 10 and 8. So since that, so there was a group, so another group which is a group 2, so which can also form a quad. So now quad 1, so this is quad 1, so which makes minterm 5, minterm 7, minterm 13, minterm 15. Quad 2 is formed by 0, 2, 10 and 8. So next we'll move to your minimization or your the common variables of this all the 4 minterms. So now the common variables for this all minterm row wise, it is q, where p value is different, only q value is same. So and the value assigned to the q is 1. So hence we need to represent in a product term q without complement. Next, in a column wise, RS belongs to 0, 1, 1, 1, where 0 and 1 belongs to R. This one belongs to S. So its second bit belongs to S. So S is common and the value assigned to the S value is logical one. Hence, your product term of quad 1 is QS. So first quad minimal expression is QS. Other product term is QS. Next, in the same manner, quad 2. So quad 2 is 0, 2, 10 and 8. So now row wise, so for 0, 2 it is 0, 0. Row wise for 8, 10 it is 1, 0. 0 is assigned to Q. So hence the first common variable is Q value with 0. So we will write with a Q bar. Next, in a column by 0, 8 belongs to 0, 0 of RS and 2, 10 belongs to 1, 0 of RS. So now the common variable here it is S. So where S value is assigned with 0, hence in your product term S is one part of your product term. So which will have your S value 0, hence S bar is represented in the product term. So now the minimal expression is nothing but these product terms of each group are summed, or we have to add all these product terms of each group. So now when you add these all the product terms of each group, we got here the final minimal expression, which is QS plus Q bar S bar. Now if they ask you to design using your logical gates, so in order to construct the logical diagram of this minimal expression, I need to use two AND gates with one input which is of QS. The other input is connected with the Q bar. The other gate AND gate is connected with Q bar S bar as the inputs, which will give you the product term of Q bar S bar, and one OR gate we need to use in order to obtain your minimal expression. F minimum is equal to QS plus Q bar S bar. Now upon getting this final minimal expression, it should not be further reduced. So now, so this is our actually it is in the form of A bar B bar AB. So you can write or you can replace with a special gate, which is Q is exclusive NOR with S. So ultimately our function is we also implemented with the basic gates using two AND gates with one OR gate, or simply you can also use one exclusive NOR in order to implement your function with the connected inputs. QS as your minimal expression is equal to Q bar S bar plus QS. So like this we're going to minimize your function. Next example, f of ABCD is equal to sigma m of 0, 1, 2, 5, 7, 8, 9, 10, 13, 15. Now, so we also have an additional two minterms with the last previous problem here. 1 and 9 is also included. Now, if you include that 1 and 9, so now already we discussed here. So this quad 1 will give you the minimal expression as, now the variables are here. The earlier problem is having, the first problem is having the variables, input variables are PQ. Here they have mentioned the variables are A, B, C, D. So we have to write your minimal expression in terms of your given variables A, B, C, D only. Now if you write it, first group will give you the minimal expression BD, and corner minterms can give you the minimal expression which is B bar, D bar. Now this, in order to cover your minterm 1 and minterm 9, so I'm using already covered minterms of 5, 3 in your first group. So this belongs to the third group, which is your blue group. We have indicated with the color to separate all these groups. So now this blue group can give you the minimal expression is C bar D. So the final expression is addition of these all the group terminals. Here it is equal to, not equal, so it is equal to, so final expression is F minimum is equal to BD or of B bar, D bar or of C bar D. So like this, so we have to minimize your function by checking there or form it into a large group. So here the large group is octet. So because here the number of minterms are more than 8, but we can't form because of our given minterms cannot form a octet. So octet adjacency is not there. So then we move to a next priority with the quad formations of your given minterm. So with that quad formation, we've got almost 3 quad groups we have it. So each quad group can eliminate 2 variables which is not common from your each group. So A, B, C, D are the variables. So by just verifying the groups, so here A, B is not there, which are not common. Here we doesn't have A and C. Here we doesn't have A and C. So a quad can eliminate 2 variables. A pair can eliminate 1 variable. An octet can eliminate 3 variables from your each group. Next, minimize the following Boolean function, which is given with the f of a, b, c, d, 4 variable again. So with the given minterm 0, 1, 3, 5, 7, 8, 9, 11, 13, 15. So now map your function based on your given map, k map, 4 variable k map according to your given minterms. So map your functional values of 1 into the corresponding. Then we start here doing the grouping. So now there is a possibility. So we can form an octet because 1 is adjacent to 3, 1 is adjacent to 5, 3 is adjacent to 7, 6, 5 is adjacent to 13, 7 is adjacent to 15, 13 is adjacent to 9, 15 is adjacent to 11, as well as this 9 is adjacent to 1 because it is in top layer and 9 is in bottom layer. The 3 is adjacent to 11, hence we can form an octet. So here this blue group which is a octet. Now as we discussed that octet can eliminate 3 variables which are not common. So now AB for all these 8 minterms, AB are not common. Only the same variable A is equal to D. So hence here we obtain the minimal expression of the first group is D. Next, the remaining 2 minterms are left with 0 and 8. So there was a possibility with the, if I only wanted to cover with the uncovered minterms, then we can have a pair. But if I use already covered minterm to cover your uncovered minterm, then we can form a large group. So always, so you could prefer, though if your some of the minterms are already covered, in order to cover your uncovered minterm, choose your big group, not your small group. So since here I have given that, so there is a possibility, so we can do the pairing here, but we prefer the quad by using the already covered minterm of 9 and minterm of 1. So with that, so many your number of variables are reduced here. So row wise, the common variable for this 4 minterms are b bar, and column wise the minimal variable is c bar. So hence our minimal expression A is equal to d or of b bar c bar. Next, we also have one more example, which is sigma m of, so 3, 4, 5, 7, 9, 13, 14, 15. Now this mapping can have only possibility of pairing. So we don't have a 1 here, we can't form a quad. We don't have 1 here. If you have 2 ones here, you can form a octet. But there is a possibility of pairing only. So hence we have total 4 pairs here. 3 is paired with 7. So 15 is paired with 14. 13 is paired with 9. And 4 is paired with 9. So now, so this blue group will have the common variable as same variable as A bar and CD. A bar CD, A bar CD, A bar B. Blue group is A bar B, C bar, and green group is A bar CD. Here orange is A B C, and this purple will have the common variables are A row wise, and in column wise it is C bar D. So by ORing all this, so we can have your minimal expression. Upon getting the minimal expression, we need to draw the logical diagram. This is for today's session. So minimization of 4 variable using 4 variable K-map method. So in next class, we are going to minimize your 4 variable SPOS functions. Thank you.